This is Pard from FTC Team 7477, and today we're going to be talking about the basics of programming motors in FTC. So we've done our op mode and basics of Android Studio videos, and today we're going to be actually getting into writing code for FTC use. So you want to start with navigating to the three files that we created earlier in the op mode video, and for the sake of this video, we're going to use a linear teleop. Now, remember, we created two teleops. So if you wanted to, you could use the op mode teleop, but for this tutorial series, I will be using the linear op mode teleop, and I recommend that you do the same to follow along. So motors are the basis of FTC use. So they're used in your drivetrain, they're used for most of your modules, and we're going to be looking into the basics of programming them. And the first step when starting to program any module on your robot in FTC is to initialize it. And we want to configure it with the robot so the robot actually knows that you have a motor. And the way we do that for DC motors is there's a specific object called DC motor that we create a variable of. And this is the DC motor object shown right here. So we're going to use this, and we are going to create a variable name, motor. Let's call it motor1. So remember, this is the actual object. It is similar to a double or an integer or a string for Java. And this is your variable name that we will be using later on. And in FTC, there's something called the hardware map, which is where you configure all of your moving parts and all of your modules of your robot. It is where all the things that plug into your RevHub go that are configured on your phone. And the way we do this in the code is by using the variable name and setting it equal by saying hardware map.get dcmotor.class. And here we put whatever the device name is. So we're just going to call it motor1. Now, a little disclaimer on what this actually is. It's telling the hardware map of all the things plugged into a RevHub, all the parts, to get from the DC motors, motor1, which is the name of it. So the way this works is when you plug something into your RevHub, you need to configure that on your phone. The name you use in the configuration must match the name used here. If they don't match exactly, the program will throw an error while trying to run. However, this is your variable name that will be used to reference the motor in the code. In the code, you can use any name you want. It doesn't really matter. So now that we know the first initialization from the hardware map and configuring the motor, we're going to get into some setup functions for the DC motor to make it run smoothly. The first one is setting the direction of the motor, which means that when motors are set power, they will spin in a specific direction. It could be clockwise or counterclockwise. However, you can reverse this using the set direction method. So if I do motor1.setDirection and choose a direction, let's say forward, this will tell the motor to spin forward from so it will set the direction to forward. This is a default direction, so does not really need to be used unless you set it to reverse previously. Now, there's another line called motor1.setDirection, and this time it's reverse. And what this means is if I set the motor to positive power, it will actually spin in the reverse direction than original. So this can be done with wheels or something, any wheel or any module that you want to move in the opposite way when set a power. So that is setting the direction of the motor. Next, we're going to be talking about zero power behavior. And what that means is how a motor behaves when it is set to a power of 0. It can do one of two things. It can brake immediately, a hard stop, or it can coast to a stop slowly. And you can choose which way it does this. So, in order to brake, we want to use the set zero power behavior method. And if we wanted to brake to a hard stop, we are going to choose, let me just fix that. We're going to choose the brake method, which means it will come to a hard stop when you set it to a power of 0. The other zero power behavior is floats. And what this will do is coast to a slower stop instead of just doing a hard stop. This can be used for a variety of things. If you need something to stop immediately, you use brake. If you want it to slow down gradually, you use float. And next, we are going to look at DC motor, we're going to look at setting modes for DC motors. And this pertains to encoders. And essentially what encoders are, it's a plugged-in wire that keeps track of how many times your motor has spun through a unit called ticks. We will go further in depth on encoders in another video, but we will cover the basics today. The motor 1 has a function called set mode. And what this does is set a specific mode to the encoder. So I can choose, there's 4 modes and we will be covering 3 today. The first one is run using encoders. It will look something like this. And what this does is it tells the motor to use its encoder to manage any power that's set to it. When you use an encoder and you set a power to a motor, it will ensure that the motor is running at that power consistently, no matter what the battery it is. So when you're using a motor that needs to spin at a set power, it is a very idea to use run using encoders. There's another mode, and if you guessed it, this one's called run without encoders. Run without encoder. And this is the opposite of run using encoder. It will not use a plugged-in encoder to manage the power or track the position. Now, the third mode we'll discuss today is stop and reset encoder. And it will look something like this. And what this mode does is it takes whatever your encoder value is currently in ticks, saying how many times you've spinned, to 0. So let's say I've spun 3 times. My tick value might say 800 on the encoder, but I want to reset it. The stop and reset encoder would set the encoder to 0 and set it for counting ticks again. So that is the 3 motor modes. And now we have covered all initialization functions and setup functions for the motor. So now we're going to be looking at actually setting power to the motor. So the command used for this is motor.setPower. And it takes in, motor 1 in this case. It takes in a value from -1 to 1 inclusive. So -1 will spin backwards, 1 will spin forward. If we did the reverse at the beginning, -1 will spin what the original 1 was, and 1 will spin what the original -1 was, if that makes sense. So if I just chose 1, what this will do is it will spin the motor in whatever direction it is set forward at the beginning at full power. I can also do a value in the middle, like 0.5, which will set it at a slower speed. And if I do a negative number, it will spin it the opposite direction. Now there's one other thing that we were going to discuss today, and that is the DC motor X. DC motor X is a special class of motors. It's a different object name. So we're going to create another DC motor, but this time it's going to be a DC motor X. And we're going to name it motor 2. It is a similar initialization to the previous motor, except for the fact that instead of DC motor.class, it is DC motor X.class. We are going to name this one motor 2 as well. An example of a method that is exclusive to the DC motor X class is the set velocity method, which I will show here. And the set velocity method is sort of a more accurate set power method that sets the rate of the motor moving in ticks per second. So it is not limited from 0 to 1. I can set it to whatever I want in ticks per second. And this is more accurate than set power, and you can set it to move to more faster and reliable speeds. So this is often used for things such as flywheels, that need to be fast and accurate. And set velocity is the preferred method used when you are setting a motor to a power when run using encoders, and you're using your motor with an encoder. If I show you motor 1 and try to set velocity to it, it will not work, as it is not a DC motor X, it is only a DC motor. I encourage you to play around with these functions a bit more, as there are many functions, as you can see, that are not discussed in this video. You can find links to go to pages that have all the motor functions and read through them, and they will greatly help with your understanding of motors. That is it for today. Thank you for watching.